computer? Okay, make a start. Does anyone know what the law of Demeter is? Or the principle of least knowledge? Yeah.
No, I didn't know. Your inheritance structure shouldn't be too deep, so you shouldn't have to like worry about implementations like 8 files away in your code.
Yeah, that's one way to put it. Don't have to worry about implementations that are sort of several hops away. What's another way people think about it? There's a little saying that talk about that. Yeah.
As in be able to do all tasks and get to do something that fast rather than you generically, so you're not planning out the main, I guess, within a function within a class, you should expect that class to be able to do it as you call the function.
Yeah. So we delegate to sort of what the class we're immediately talking to rather than sort of reaching across. Any other ideas? There you go. So there's a nice little saying, the law of Demeter, which is you can only talk to your friends. Which is to say that if I'm an object here, let's I think the kind of canonical example is like, let's say I'm a car. And the car has an owner, right? Private field owner, which is an owner object. Got ourselves an aggregation with our owner class. And the owner also has an address, again, private field address. I can never spell this word. Same thing, aggregation. And I want the address. So you say, okay, well, let's say I've got a car with me and I want to get the address. So you say, well, let's go car dot get owner, right? Because there's a getter here somewhere. And then that also has a getter for the address. So the car dot get owner dot get address. What's wrong with this?
I guess like you need to know the methods in owner in order to get the address or the person who owns the car.
Yeah, that's like you any method that's public, like get address and similarly get owner here, they're public to absolutely everyone in the code base. You could call, a class that lives over here in the corner that has some public methods. So it's less about kind of knowledge of the interface itself, and that's what we use the access modifier for. But something more about kind of what's going on at a deeper level here. Who thinks that this looks a bit ugly? Yeah, a little bit. Okay. So the problem here is that as the person who's trying to use the car, right? Like there's some other class which has got a car object, public, blah blah blah, and then there's some car thing here. We're trying to do this car dot get owner dot get address, and we're trying to reach over multiple classes and play this kind of almost like path and parcel thing here, where we go, okay, well, let's get the owner, and then let's get the address. And this is what we say when we mean. Sorry, this is what we mean when we say you can only talk to your friends, because the car class, its only friend here is the owner class, right? There's an aggregation, there's a link between the two. But now we're saying, actually, I want to go all the way across into the address class and grab that piece of information. And you think, well, that seems okay. Like, what's wrong with that? You're just kind of doing a bit of hopping to get there. And what it creates is this thing that we don't like in software design. And it starts with the letter C, and I'm going to play Hangman. There's actually 2 words I want to talk about today. And I like doing this whenever we get to this point in the course. It's a bit of fun. You have to guess what the 2. Yeah, I feel like most of you probably get them quite quickly, but right. You got to guess. We'll start with this word. Yeah. Yes. Let's start with C. Yeah. You guys already know what it is. I last part didn't know what the word was, so we looked at one by hand then. Yeah. Yep. All right, someone want to guess the word? You shout that. Coupling. What about this one? Yeah, it's here. Oh, it's very close. Very, yeah. Right. We'll talk about this one in a second. Coupling. So when we have any sort of relationship, whether that's a semantic, wibbly-wobbly meaning level, like we were talking about last week, and we're doing the requirements analysis, right? Like a car as an engine, as just like an idea. And then when we sort of actualize that in a design, we say, well, a car has an owner, right? So there's coupling between these two objects. Now, we need that coupling in order to be able to do anything, right? Like, we said that coupling, we sort of have this negative connotation towards coupling, right? That's, the coupling's bad, but you need coupling to be able to have any sort of, meaningful interactions in OO. And so what we like to say is you need coupling, you need to try and keep it to a minimum. So what this does is add extra coupling that we don't need. All right, so you think, well, what could we do to fix this? And this is an interesting question because it's a very isolated example, but if we were going to refactor to try and remove this smell, what would we do? Method 4. Yeah. We can do something along those lines. Does anyone want to take a stab at like what code you'd write? Or what method we could have in one of these classes? Yeah, get owner address. So you'd have something like instead of get owner, and then we've got plus get owner address. And so you turn this into from 2 getter calls into just 1. Blah, blah, blah. Now, the thing is, this is a very self-contained isolated example, and the problem is you kind of haven't really fixed the problem here, right? You've now just got a method here that says owner dot, like you just put the getter inside this this owner method, and you've just sort of moved around the problem rather than necessarily fixing it. Now I know this is the example we give in the lectures and stuff, but I just want to get you to think about the design at a bigger scale, right? A bigger picture idea of, when we see these design smells, what do they mean? And are you, when you fix a design smell, I'd like you to think of, you go like a tree, and maybe there's some fruit on the tree, right? These are fruit, and then one of the fruit's rotten. The tree, and then the rotten, right? Maybe the rest of the tree is okay, but maybe there's actually some rot that's going on deeper in the tree. Bit of a weird metaphor. But there's this idea in I don't know, just like general culture called like the fruit of the poison tree. Have you ever heard of that? And it says that, well, there might be these things that actualize themselves like these design smells, right? You think that's a bit weird. But instead of actually going and fixing the underlying problem, you fix the smell. And so in this case, like you could fix this here and get rid of that bit of code, or in this case, fix the fruit. But the tree is still poisonous and it'll still keep producing poison fruit because you haven't fixed the problem. So I would encourage you to like think about that when you are diagnosing and trying to refactor stuff. Because if you can sort of peel back what's going on and then say, okay, well, here's the actual problem. But if we fix that, then we fix everything else. Then that will help you in the long run. Now we haven't even, I've just spent like 10 minutes talking, which is great. Let's talk about this example here. Now, again, we just talked about this code smells. What are some smells here? What are some poison fruit that you can see in this example? Yeah, I've got nested for loops and if statements. Looks pretty diabolical. It looks like from your code, right? Okay, so that's the smell, right? What do we think is the underlying problem, right? What's at the root of the tree? I'm gonna give you 30 seconds to talk about it in your groups and then you can come up with an answer. What is the underlying design problem here? And as you do that, I'll show you something else. So this is connected to the trainer, the seminar classes. Here's the trainer class, and here's the seminar class. Have a think about that, and 30 seconds talking to groups. All right, time's up. Doing a lot of thinking and staring at the code. Does anyone want to have a guess? What, like, if you look at these two classes, what's very different about them?
Yeah, one's very like complicated, the other one's not.
Yeah, one's chunky out and the other's just like, hi, here's a couple of fields, right? What do you think that might indicate? Sorry? Loose coupling or maybe tight coupling? So that's right. So as in you'll think about like coupling as when we want things to be loosely coupled, right? There's some coupling so that we can do stuff, but there's not so tightly coupled that when we try to change things, we have to go back and fix a whole lot of stuff and things start to break. Yeah, so we've got some tight coupling going on. What's at the root of that though? You can, and like when you're just thinking about design problems, you can think, well, you know, we've got this smell, right? All this nesting going on. Okay, maybe there's some tight coupling going on. Why is there tight coupling going on? You kind of have to keep digging deeper and deeper. Anyone else?
Yeah, so basically, method functionality is affect to this much certain this everything down in the.
Yeah, essentially the training system class is being too greedy, right? Because all this functionality is going on here, when in fact we could sort of more evenly distribute it. And I don't mean that in the sense that you have to have like the same number of lines of code, but you see like all this stuff is about a seminar. If you think about it, you go, let's go through all the trainers, sorry. If you go through all the trainers and then now we're just talking about one trainer, maybe that could go in the trainer class. And similarly, here's some stuff that's, you know, about seminars that could go in the seminar class. So what we want to do to fix this is to delegate responsibility. And you like, I see this in students code all the time. It's just like the super classes or some classes doing extra stuff which it doesn't need to, and the solution is delegate, push it into another class. So let's do that. And enough of me talking for a while. So for trainer and trainers, what we're going to do is try to do the same thing. We're going to do a booking, except we're going to do it in the trainer class. So I'm going to make a method here, which is public, we'll say local date book training. And we're going to take in the same thing as we do here. And local, oh, sorry, list, local date, availability. And now what we're going to do is just go copy and paste, right? And this all works because everything in that for loop pertains to stuff that's about the trainer class anyway. And what we can do here is just, we can change this to say what? Instead of looping through trainer.get seminars, right? We have to go through the getter. We can say seminars, yeah. Okay, cool. So we go through all the seminars, we check the availabilities, blah, 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 return available. And then if we got to the end of all the seminars and nothing worked, we just say return null. And then that's happy. Okay. And then for each trainer and trainers, we're going to say trainer dot book training employee. And we'll say local date result equals that. Now, if results not equals null, then return result. And then again, same thing, we get to the end of all the trainers and none of them had any availabilities, we return null. Cool, are we done? Yeah. Oh, good. Who reckons that we're all finished and the code's perfect now? Is that better? Cool. Who reckons that we can still make some improvements? Yeah. Exactly. So we can do the same thing. We can further delegate because everything in here is just talking about the seminar. It's not talking about the trainer. So in the seminar class, we again are going to do the same thing. Public local date book training, string employee list local date. Like so, and then let's just go copy. Oops. And paste. Cool. All right. Now we've got all this stuff here. Seminar, blah, blah, blah. That's interesting. Let's just write the outer bit first. So we'll say local date result equals seminar dot book training. And do the same thing as we did before. Check for null and return result. And then again, we get to the end and return null if nothing happens. Now, we talked about code smells before, right? These poison fruit, right? Fruit is poison free. And things that indicate to us that maybe something's not right. And the thing about this is like these sort of design problems is like it's often not immediately clear, right? Like a lot of design problems aren't like that, what we just had with the forms where it's bleedingly obvious that it's a problem. Maybe it can be a lot more subtle and it takes us a lot longer to identify and understand it. And what we can do is kind of use a checklist of potential code smells. So there's another code smell in the block that I've highlighted here. And does anyone know what it might be? It's got a name. But just sort of looking at it, you think what's sort of wrong intuitively about this code? Yeah. Oh yeah, that's true as well. Like you're going inside and modifying this list. That's definitely like part of the problem. In breaking calculation as well. There's another like let's say this was back in even the trainer class. What do you notice about this? It just doesn't quite sit well. The variable that actually inside the class. I'm not sure if that's sort of. I like the fact that we've moved it inside the class helped. But let's say let's say we had this still over here. What do you see a lot of? Like what's the most common word in that line that block of code? Seminar, yeah. And we've already made the decision to delegate responsibility, but this is another smell, right? Another indicator. You're going seminar.get this, seminar.get that, seminar.get that. And it makes you think, oh, maybe, if we're just calling the seminar constantly, that this should be inside the seminar itself. This is a smell that we call feature envy, which says, if you keep enviously saying, get me this, get me this, get me this, then it's an indication that you need to delegate responsibility because the functionality that you're trying to work with is in the wrong spot. that make sense for everyone? Yep. Happy days. Okay. So now we just need to change this to start. We don't actually need to use the getters. And we can say attendees dot size, and then same thing. We can do this properly and not reach through a getter to access someone else's list. And then we check all that and then just return null at the end. And that's it. Is there anything else anyone thinks we could do to improve the quality of this code? I think it's pretty okay. I think like the thing I don't like about this is there's still this whole thing of like you're kind of doing the same thing here and here. You've almost got like it's almost identical. And you know, maybe that's okay. Maybe we could make it a bit more concise. There's a way we're going to do this sort of like really iterative stuff where you do all these like all this control flow. We can actually make a lot more concise using programming concepts that I'll talk about in the next exercise. But it seems okay, you know, you have the system and you look through all the trainers, look through all the seminars, and then look for a free seminar. Maybe there's more optimal ways to do it, but at least in the sort of, you know, context of this example, we've improved the code and we've made it better with refactoring. And that's like ultimately, like any refactoring exercise, and this will be very true of assignment 2, which starts next week, is you just want to make the code better. It doesn't have to be perfect, it just needs to be better than it was when you get it. Are there any questions on this example? Cool. Now it's 6:30. We have a few options. We need to talk about the stream stuff. We need to do the design by contract very briefly. Do you want me to talk through this? Because this will take some time. I'm just going to give the same example as the one in the lectures. Do people want to talk through the sculpt substitution principle, or are we happy to move on? Who says let's go? Who says move on and talk about streams? All right, let's talk about streams. So, a lot of boilerplate in code. Oh, we need to talk about cohesion as well. We'll do that at the end. A lot of boilerplate in code comes from things like, you know, we need to do this for loop and this if statement and you know, the fundamental building blocks of everything you learned like 1511. We get to a certain point, like actually, I'll go back to the code we just looked at. And it becomes like a bit, you know, this is like 6 lines of code. That's okay. Maybe we could make it a bit more concise because it's really not doing a whole lot. And does anyone know what sort of paradigm of programming these, you know, like for and if and all these variables and stuff belong to? Starts with an I. Like hang for it again. Sure, let's do it. The last one was too easy. That was a practice round. Right. Good. I T E I V E. So I'll get it like there. Yes, it's not right. Oh, hang on, sorry. Oh man, okay. Like you know, you got the word wrong. It's not right. You don't get all the letters that you got correct. Anyone else? No.
But why did I get the letters though? Otherwise,
Because you guess the whole word. You should get into the letters.
I mean, you can't just give me all the. Look, if you give me all the points, you know what I mean? This is you do the whole thing.
I wouldn't do the whole
You do most of it, so you get through like you took away enough points as a.
Okay. Every word you say, I'll draw a thing for. So all the words you just said are that.
That's not good.
I don't think it is bad. Does anyone want to get back to that? Yes, and imperative. Okay. What does imperative mean? So imperative programming languages are ones that where you follow a set of instructions. Like here's a set of things you have to do. That's what the word imperative kind of means. What you call it? Like, I think there's probably some Latin root for it, but essentially it says do this, then do this, then do this. And, you know, obviously we introduce conditionals and control flow and for loops, and that's how we write code. What if there was a way to do it that was a bit different? And this gets us to functional ideas, which really you've been working with for a while, and maybe just haven't known it. So what we're going to do is we're going to rewrite this. We're going to rewrite this block of code using a lambda, which says, instead of having a for loop, I'm just going to run a function. So what we'll do is say strings dot for each. And then what we do is provide a function as an argument to this method. Does anyone feel immediately confused by that? Okay, so, I assume you're like at least semi-familiar with the idea of lambdas and functions as first-class values. And what I mean by that is we're going to say, okay, I'm going to provide it this function which gets given a string s, and then we're just going to print it out. Like so. So this is like your parameter to the function, and then this is what we do, right? Because we're trying to rewrite this bit in using a for each. And what that'll do is it'll inside this function iterate through and call, inside the for each method, it'll iterate through every string in the list and then call this function and pass in each member of the list as a parameter s. Pretty clear? Yep. Cool. We run that, and as you'd expect, it does the same thing twice, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right. Now, what if we start to sort of aggregate operations or chain operations? So in this example, we've got, again, some strings. We want to convert them to a list of integers, right? That's a pretty common task. And, you know, like we've got this whole thing of, okay, we need to set up an ints list. We go to just ate my words. We need to go through each string in the list and blah, blah, blah. You know, it's like quite verbose. It's only 3 lines, but maybe we can make it more concise. So let's do that. Let's get rid of, actually what we'll do is keep the code and then just say system.out.println strings2.stream. Okay, we'll talk about a stream in a second. What are we going to do? Map. And I'm going to write this out first and then explain it later. Integer pass int dot collect collectors dot to list. Now lots of stuff going on there, but we'll run it first. And it does 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. You think, well, this is a very long line of code. What's going on here? And when you're doing like stuff with strings, you'll have this sort of thing happen a lot, and you'll see this a lot. Particularly the assignment 2 code base we're going to give you has a lot of stream stuff, and you'll see it across like multiple lines. So really, like, I think the linter will probably give you specific guidance on how to do this, but something like this is okay, where you have it just like, you know, 1 dot per line. I'm going to leave it like this for now so we can talk through it. Does anyone know what a stream is conceptually? Okay. Who knows what a stream is like in real life? One person, wow. Very well educated class. Right, like, you know, it's like a body of water, you know. Like a river, I mean, rivers are not streams, but it's this, you know, it's very, I don't know, it's this sort of embedded idea of like, really wobbly body of water, right? And I think what's that got to do with code? Well, when we convert something to a stream, like what we're doing in this first part of the statement is we convert an array list to a stream. And you can think about it as being like, you know, I start out with, here's my array list, right? It's, you know, super blocky and rigid. And then what we do is you say, convert it into a stream. It becomes this wibbly wobbly, right? So here's our stream. And what we're going to do is all the kind of elements of the array list that we had before that were rigidly stacked together and now just sort of floating along the screen. I think that's kind of a little bit weird, but do you get the idea roughly? Okay, next thing to continue along this rather strange analogy is I really like Winnie the Pooh. And in Winnie the Pooh, they play this game called Pooh Sticks. So what they do, here we go, is they each get a stick and there's a screen and they have a bridge, which is on top of the screen. Here's, me doing it, mates. And what they do is they all drop their sticks in at the same time on one end of the screen. They did all their sticks. And then because it's a screen, right, it's all continuously moving, the sticks sort of float down the screen. And then the first stick to come out the other side of the bridge wins. That's not super important. But you think, what has this got to do with functional programming? Well, what it allows is for this very loosely coupled approach where we can say for every stick that's coming out of the bridge, metaphorically speaking, or every item in the array list that's sort of floating down the screen, let's apply a function to it. So then we're going to get this thing here and say, well, I'm going to turn it into an integer, right? And maybe once it's done, it keeps going further down the screen, and then we'll apply another function and then another one. And that's what we do when we are mapping the elements here. Does anyone not familiar with the idea of a map function? Or done it like Python or JavaScript, right? It says, given a function and an element, I'm going to run this function on that element, or a list of elements. So for every item in the stream that passes through, map says, okay, turn it into an integer. Now this little colon syntax is what we call a scope operator. If you do C++ ever, you'll see this a lot. But it essentially, another way you could write this is you get a string s, like we did before, and we can say integer dot pass int s, right? Like same as what we did up here. And if you really want to, this is another thing about lambdas in Java, is you can write essentially your own function here if you wanted to. So I'm going to make this span across multiple lines. We become then constrained by like normal programming things where you have to actually write code. You can code up here, you can do stuff, and then just say return, because map expects the function that you provide to return a value, which is the mapped thing. So this is the same. This is the exact same as what we had before. Obviously, the other one's a lot more concise, and I encourage you just like to play around with it, see what works, and try and use this operator where you can, because it looks kind of cool, looks a bit more clean than the other syntax. Okay, so we map it. Now, what do we reckon this last bit does? If you think about the fact that at the end we have an array list, right? And we did the other, the imperative code. What does the last part of this statement do? Yep. Yeah, it puts it in the list. And if we go back to our screen example, right? The sticks float down the screen, or the elements in the array list, and then this last bit, collectors.collect, just says, okay, I'm going to have someone stand here and pick up all the sticks. The sticks come floating downstream, you pick them up and put them back into the array list like we had at the beginning. And that's all this says. Just collect everything that comes down the stream and put it into a list. That's what this argument here says. Does that? Oh, yeah. That's a good question. Let's have a look. So it returns a stream, and this is a really interesting concept. You guys are going to implement that at 8. which says, you know, you're given a string and you return a string. And if you think about it here, like you could put the map anywhere in the chain, right? And you have these elements flowing through the string. And the map just kind of acts as a funnel at one particular point. So that the elements inside the string might be different, but it's still the same string. You can change as many operations on as you want. Like you could do map. Maybe let's do a filter as well. You know, here's a number. So this will be an integer now. So we'll say I is less than 3. So now only the numbers less than 3 will actually make it through. So we put a filter on top of a map before. Again, filter return to screen. You can just sort of put these operations in at any point because it's all returning a string. This is very loosely coupled architecture, and this is a very sort of it's honestly really like game changing, because you start to play around with functions as first class values. You start to play around with this idea of strings, and you get some really interesting architectural patterns that actually I'm really based on. When we get to that later, but for now, it just helps us write. Like this is much cleaner than what we had before, right? You've gone from 3 lines of slightly clunky code to 1 line of pretty clean code. It's probably a bit like, it's a bit of a mouthful at the beginning. You're like, what's all this stuff? But you'll see as we kind of work with strings more and more that it will help you write much more concise code. Any other questions? Yeah.
So in terms of like what it actually does, does it do the exact thing in place of but just switch it in?
Yes, so it goes, I mean, it's not the exact same thing, like here we have a copy of this and stuff, and you know, where people just printing it out, but like more or less does the same thing, right? It goes through all the strings through all the elements in the list, converts into integers, like we did here. We added the filtering, but you can do those all in the code.
So is the runtime on the flex this as well?
I think so. I would imagine they're built like under the hood, the same thing is going on more or less, but it's just written in a very functional way that that means that you're not doing all this extra overhead with control structures. So I would imagine yeah. Like this one.
Yeah.
Yes, you could do something like again, we can write this and turn this into a whole lambda. Sorry, a whole like so it is lambda to begin with, but which is just an anonymous function, but you can add more code to it. So I could say, you know, if s dot equals or not s dot equals actually 1, then we'll print it out, you know, else something like that, and then we run it, and you can see it prints out other strings. Again, this is just a function here that gets run a series of times. I really can't emphasize how game changing this idea of functions, this variable function first class values is. You can talk about that more actually. Does anyone have any other questions? So I guess to elaborate a bit further, and this is something we talk about in the functional paradigm lecture, is what this actual object is called a consumer. So consumer, which takes in a string. And what I'm just going to do is copy paste this lambda and put it here. You can see that it's pretty happy, except for the fact that it doesn't like this, because I need to import it and a semicolon here. But what we now have is a consumer variable. This is an object, right? Like any other object in Java, except this object is actually a function. Now, a consumer, you know, think of like the Cookie Monster, right? Goes nom 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 nom, eats all these cookies, but like it doesn't produce anything, right? It sort of stops there, and like this function does here, where it takes the input, it doesn't produce any output. Whereas another type of what we call functional interface is a function where you could get given a string and I don't know, return an integer. and we'll import this. Sorry, oops. Create constant, that's not what I want. I want to import. Sorry. All this function is going to do is get given a string and say integer dot pass int s. Right? It's a benign abstraction. It doesn't do anything. But what we can do is call it a function. And now I can use this like anything. So, f dot apply 1, and that will return the integer 1. And you notice here that this takes in a value and returns value, right? It's like a toaster. You put in bread and get out toast. So there's a bunch of different functional interfaces. I encourage you to read into them and understand, like, where you use different ones, where you use a function that doesn't take anything but still returns the value. Focus apply. Lots of different examples. Anyway, any other questions on this functional stuff? No. Let's talk about design by contract and then actually wrap up on time for once, so that we can talk about, so we can, get help with assignment stuff. All right, design by contract. Who knows what it is?
You give the user some specific conditions for using your code rather than your code itself. And
yeah, that's pretty much it. You instead of and I'm going to use the assignment as an example, because people love to come up with every possible edge case under the sun that there could ever exist. Like, let's find one comment here on the confluence. Let's have a look. Yeah, okay, so this one. I screwed up here the other day, actually, to find who it was. So someone says, oh, what happens if you have a file that's got 0 bytes in it, right? And when you're doing the assignment, it's like, well, the file has 0 bytes, then there's no transfer needed, right? Because if you have send the file, then there's nothing to transfer. It's a bit of a weird case. Now, in sort of defensive programming, you think, oh, man, I now have to account for that, right? Because what if someone else tries to send a file with 0 bytes? And my code has to use that, otherwise my code is going to break. But what we say here is, if in that case, the behavior is undefined. And you can think about it as like, what would you say? Here's my spec. And the spec is of a finite magnitude, right? The spec doesn't cover every possible case because, and particularly when software gets more complex, like here and definitely for time too, you can't list every possible case, right? It's just too much. If you were like, oh, now we have to do this update spec, now we have to do this update spec, you get 5 billion spec update. So instead we say, don't worry about it, because and you guys are doing your assignments, right? It's like the client is us. And we're just not going to test it. And if we do test it, that's our fault. And that's the essential principle behind design by contract is you say, well, here's the spec, right? Here's how to use, might be a class, it might be a whole black hat controller, right? That's your whole black box, it's your assignment. It might be a web API that you're calling. And if maybe it's like I would actually I'm not gonna do it, but I can give you try to bring up a web API that here's the different parameters you can give it. And if you do something more, I'm going to do something that's not defined, right? It's out of spec. It's over here. Then it's not a defined input case, which means there's no defined output case. And the software isn't obliged to give you something meaningful, right? And when we say the behavior is undefined, it's like anything could happen, right? You'll probably just get some weird error, or the output will make no sense, or maybe an exception will get thrown. But like technically, the computer could blow up, right? Like anything can happen. The behavior is just undefined. Another way to think about it is like buffer overflows or segfaults, right? Your sort of contract with as a C program with the operating system is like, with the programs, like if you write to memory that's going to be not malloc, then any weird stuff could happen. So in this context, it's like, well, we just say the behavior is undefined. We don't write tests for it. And you can think about tests as like, you know, here's the spec, and then here's all the tests. Now tests cover everything in the spec, but they don't have to cover anything that's not in the spec. It's like the you know, like the truth, the whole truth, and nothing but the truth. It's like the spec, the whole spec, and nothing but the spec. Cool. I actually forgot about this example. So here, we'll go back to Tute. Blah, blah, blah. Oh, I should change this because we moved it. Inside the, okay, we're going to specify a contract which says, well, we have to assume certain things. We can't we're not going to check everything. So in this case, I'm just going to do add and a couple more. We assume that A and B are doubles. We don't actually have to assume that because it's enforced by the type system. So let's just say, assume that A is a valid double. Realistically, you don't even need to assume that, but let's just put it. And this is what we call the preconditions. The preconditions is like when you go to an airport. And you know, when you go to an airport, it's like you have to rock up and you have to be there on time. The post conditions is like you get on the flight and you get a shitty meal or whatever, and that gets you to your destination in time, right? The post conditions is what you as a coder have to give the client, and the client is what they have to give you, and you can assume is true. So in this case, we assume that A and B are a valid double. What about dividing? What would we have to, actually, I'm just going to change this to say at preconditions, A, B are valid doubles. What preconditions should we specify for division? B is not equal to 0. So what that says is, at precondition, B is not equal to 0. What happens if the client calls this function with B equals 0? And don't worry about what actually is going to happen. What happens in the world defined by contract? Yeah. No. Crash or you shouldn't run. So you sort of all correct and sort of all incorrect, and then the behavior is undefined. Anything can happen. Maybe it crashes, maybe it doesn't run, maybe it throws an exception, maybe the whole computer blows up. It's undefined. So now in this case, it's actually just going to throw an exception because Java has a contract that says, well, if you try to divide two numbers, it throws a what? Divide by 0, yeah, like all three. That's Java's contract part. Maybe we want to actually change the contract so that we define the case where B equals 0. So it becomes like a precondition, but we actually check it. So we say, well, if B equals 0, then I'm going to throw new, we'll say like illegal argument exception, which is a pretty common one that we use in the course, that just says B cannot be 0. And then we don't have a use case for this class, but I won't run it. So now if we give B equals 0, the behavior is still defined. And in the Java doc, we actually might say, well, if, you know, at throws illegal, and you can see it comes up for the exception when B equals 0. So this is now defined behavior that is part of your contract with the user. We could have done through Java doc in many cases. It says, hey, when you give me B equals 0, just warn you I'm going to throw an exception. So exceptions are a big part of design by contract, and they're a way for us to sort of enforce preconditions and to help something, like, because, you know, if B equals 0 and then the computer blows up, you're like, well, that's not particularly helpful as someone using this API. So we can make our contracts a bit more sort of user-friendly by using exceptions or what we call the, what are they called? Sorry, lost my train of thought. It's the you have like different types of flows. So you have the optimal, which is, happy days, this is what we can use the function for. And then you have optional, which is like an alternative use case. And the last one is exceptional, which is, when being considered. So you define the exceptional flows and then this is defined behavior. It's not just, anything to happen anymore, but it's not what you want. Are there any questions on that? I know we can do it. Sorry. Yes, exactly. It's contractual programming because you have said this is the exceptional flow. Like this is what will happen if you give me the zero. Defensive is more like I mean it's sort of more sort of way of thinking than necessarily like how you actually do stuff. So another way you could do it is maybe say like you get rid of this and say, well, I'm going to assert b not equal 0, right? You can do assertions in Java. And that is more just like a check so that we don't accidentally do some dangerous operation. Not that it's dangerous, but you're being defensive in that sense. But like the defensive methodology is more just, if we go back to the assignment, if we were doing this assignment defensively, we'd say every time someone said, oh, what about this case? What about this case? We have to update this case, right? We're doing it by contract. We're just saying, well, I don't know what's happening in this case. It doesn't matter because we're not going to test it. You don't have to worry about it. You don't have to do it account for it. What's really interesting about design by contract, and we'll see this a bit when we get to assignment 2, is like this kind of cases is, the case where a file has 0 bytes is like maybe it's defined and maybe it's not. I mean, it's sort of a case of what happens. And sometimes you can sort of put rules together to make new sort of how do you describe it? Like sub rules in the sense that, you take this rule and you take this rule and then this behavior happens. But sometimes that's not always clear. And like most questions people have about the assignment is always like, what happens if I put these two things together and, maybe this behavior is not necessarily immediately clear. And sometimes we go, oh, yep, this will happen because X, Y, Z. And sometimes we just go, don't worry about it. It's undefined. Like, not this one. Yeah, like this one. Daisy chaining relay satellites is the thing where it's possible you think about it and you said, yeah, that's the actual defined behavior. I hope that makes sense. I thought I'd talk about it more in terms of the assignment and the program. This is, you're all dealing with that at the moment, and many people always have questions about, what's in spec, what's out of spec, and that's essentially the that.
Do we need to run this? We don't need to do that because it doesn't like one
oh yeah. So as in like you have exceptional conditions, right? Like in task 3, not task 3, task 2C, you have these are the different exceptional conditions, which are like you could change this design and say, well, actually we can make it precondition, like we have the value stuff, right? The precondition is you can't have 2 satellites in the same number or satellite and data in the same way. And that's completely undefined behavior here through that. But here we've actually said, well, these are the exceptional flows, which is defined behavior. But if we wanted to, we could say, well, we're not going to worry about the situation where the max storage is reached or the max files is reached. Instead, we could say, well, that's out of spec, it's undefined. And if your system ever did handle that, the behavior we wouldn't necessarily assert anything. Whereas here, again, it's in spec defined use case exceptional flow. Any other questions? Let's wrap up there. I'm just going to very quickly call roll, and then we'll go do assignment stuff.